Hello, dear students, online audience. You are all welcome back to today's science class. The topic we have before us today is waves. Waves. What is wave? Wave is a disturbance that travels through medium, transferring energy from one point to another without causing any permanent displacement of the medium. The medium for the propagation of wave could be air, that is gas, and sometimes it could be liquid, example water, and it can also be solid. The medium can be solid, and at another time it could be vacuum. That is a place that is devoid of air, that is vacuum. So wave can be propagated inside a vacuum. Now, we said wave is a disturbance. How does wave disturb air? How does it disturb liquid? And how does it disturb solid? And how does it disturb vacuum? Now, let's take for instance, wave is a disturbance, it can disturb air. As I'm talking right now, the sound that comes out from my mouth serves as it usually causes a vibration to the particle of the air, transferring energy from me to you, the listener. And as a result of that, the air is being disturbed. That is what we refer to as sound wave. Another time, if I put on a torchlight, light comes out immediately, and that light sets the particle of air into vibration, causing it to transfer energy from me, the sender, to another destination. And that is what we refer to as light waves. There are times you can put a stone, drop a stone at the center of a pool of water. The medium, which is the water, the particle of that water will be subjected to vibration, and energy will be transferred from the point of disturbance to the side of the water. That is what we refer to as water waves. There are times, if I take a rope, one end of that rope is attached to the nail on the wall, while the other end of the rope is held in my hand. So if I wave that rope up and down continuously, the particle of that rope will be subjected to vibration, transferring energy from me, the sender, to the wall, which is the receiver. And that is what we refer to as wave in a stretch rope or string. Now we have various examples of wave. There are quite a number of examples of wave. Number one, we have water wave. We have two, waves in a stretch string or rope. Three, we have light waves. Four, we have sound waves. Five, we have S-ray. And six, we have wave in a slinky spring. We also have gamma ray. We also have infrared ray, and so on and so forth. But let us quickly come back to what we refer to as water wave. Water wave is an example of wave. Now, I've told you, when you take a stone, drop that stone at the center of a pool of water, the particle of that water is subject to vibrate, transferring energy from the point of disturbance to the side of that water. And this is exactly what is going to happen. Immediately you throw the stone at the center of the water, a circular wave is formed. Then you have something like this. From the point of disturbance, a wave is being propagated. You now see the water moving up and down, and as the water is moving up and down, there is no permanent displacement of water, which is the medium. The medium only vibrates and come back to its normal position, while the wave in form of kinetic energy is being transferred from that center of disturbance to the side of the water. This is exactly what we have here. Now, there are some things you have to take note. The first thing is the direction of the propagation of the wave. Where does the wave goes? The wave is being transported, is being transferred horizontally. It keeps on moving that way. This is the direction of the propagation of the wave. Now, the second thing that you still need to take note is the direction of the vibration of the medium. The medium, which is the water, it vibrates. It goes up and down, up and down, up and down. And that is the direction of the vibration of the medium. Now, if you look at the direction of the propagation of the wave and the direction of the vibration of the medium, you notice they meet at angle 90. That is to say, they intersect at angle 90. And that is why we call it perpendicular. So the direction of the propagation of the wave and the direction of the vibration of the medium, they meet at angle 90. They are perpendicular to each other. And that is why we say water wave is a transverse wave. It's a transverse wave. Water wave is a transverse wave because the direction of the propagation of the wave and the direction of the vibration of the medium, they are perpendicular to each other. That is transverse wave. Now, in the laboratory, there is an apparatus called ripple tank. This apparatus, we use it to demonstrate the behavior of water wave, especially when the medium, which is the water, is disturbed. So the apparatus in the laboratory that is used to demonstrate the behavior of water wave in the laboratory is ripple tank. Now, let us look at another example of wave, and that is wave in a stretch rope or string. Wave in a stretch rope or string. If I hold one end of a rope, holding it with my hand, then the other end of the rope is attached to the nail on the wall. Then I wave the rope. I move it up and down rapidly, continuously. What will happen? The particle of the rope will be subject to vibrate, transferring energy from me, who is the sender. I'm the one that caused it. Energy will be transferred from me, the center of the disturbance, to the wall, which is the receiver. And then when you watch it, there are two things here that happen. The wave, the direction of the propagation of the wave is going to be horizontal, while the direction of the vibration of the medium, which is the rope, is also vertical. So if you watch the direction of the propagation of the wave and the direction of the vibration of the medium, they meet at angle 90. They are perpendicular to each other. And that is why we say waves in a stretch rope or string is a transverse wave. It's a transverse wave because the direction of the vibration of the direction of the propagation of the wave and the direction of the vibration of the medium, they are perpendicular to each other. And there are other examples of wave that usually display transverse a wave. That is, the direction of the propagation of the wave and the direction of the vibration of the medium, they meet at angle 90. They are perpendicular to each other. Other example of such wave that behave like that, they are light wave. Light wave is a transverse wave. Then we also have S-ray. S-ray is an emission, is also a transverse wave. Then we have gamma ray. Gamma ray is equally a transverse wave. We also have infrared ray. Infrared ray is a transverse wave. Then we have another one, radio wave. All these They are examples of transverse wave. Why are they examples of transverse wave? They are transverse wave because the direction of the propagation of wave is perpendicular to the direction of the vibration of the medium. I want to be clear to everybody. That is very good. Now we want to quickly go into class assessment. Here is the class assessment 1. The question says the disturbance which travel through a medium transferring energy from one point to another without causing any permanent displacement of the medium is known as dash. The disturbance which travel through a medium transferring energy from one point to another without causing any permanent displacement of the medium is known as dash. A. Momentum. B. Work. C. Acceleration. D. Wave. The most appropriate option here is wave. Wave. Class assessment 2. The type of wave in which the direction traveled by the wave is perpendicular to the direction of the vibration of the medium is called dash. The type of wave in which the direction traveled by the wave is perpendicular to the direction of the vibration of the medium is called dash. A. Longitudinal wave. B. Electromagnetic waves. C. Transverse waves. D. Mechanical waves. If you remember, the most appropriate option is transverse wave. Transverse wave is the type of wave in which the direction traveled by the wave is perpendicular to the direction of vibration of the medium. Class assessment 3. Which of the following wave is not transverse? Which of the following waves is not transverse? A. Light waves. B. Seawater. C. Radio waves. D. Sound wave. Which of the following wave is not transverse? Now, just like you have been told, the one that is not transverse, number one example, sea wave is transverse. That is to say, the direction of the propagation of the wave is perpendicular to the direction of the vibration of the medium. So, sea wave is one of them. Sound wave. Then we also have radio wave. Then we have light wave. So the one that is not part of them is sound wave. It's not transverse. But light wave is transverse. Radio wave is transverse. Sea wave is also transverse. That is water wave. Now, class assessment 4, before we continue the class. The apparatus used in the laboratory to demonstrate the behaviors of water. Water wave, when the medium is disturbed, is referred to as dash. The apparatus used in the laboratory to demonstrate the behavior of water wave when the medium is disturbed is referred to as dash. A. Richter stand. B. Gold leaf electroscope. C. Ripple tank. D. Micrometer screw gauge. The apparatus used is ripple tank. Ripple tank. I want to believe it's very clear to everybody. Now we want to continue the class, but then I want to remind you that you should try as much as possible to subscribe to this channel if you have not done so.